to Shenzhen next week. Oh, we are live.
Some of the friends are going there. But...
Yeah. Hey, looks like we're live here. So greetings, fellow nerds. Welcome to another episode of Between Two Nerds, where we talk with prominent guests about all aspects of the networking industry, from protocols old and new to industry trends and drivers to up-and-coming technologies, and, as always, things you need to know to further your career. And that includes new and interesting books you should read, which is the topic for today. And before we get there, I'm Jeff Doyle, and with me, as always, is my friend and colleague, Jeff Tansura. Jeff, good to see you.
Good to see you, too.
And with us, we have our mutual friends, very old friends, Mahesh, Michal, and Himanshu. And we're going to be talking about their brand new book. Let me get it centered here. If you want to know their last names, there they are, including some clown that wrote the foreword for the book. But this is the book we're going to be talking about today. And great effort among all of you guys. I've done books with multiple authors before, and that's an adventure in itself, just trying to get the same voice across the whole book. And reading through this book, it definitely sounds like one author, and so just want to congratulate you on that. But for our readers, maybe just kicking off, what motivated you to write this book? And I'll let anybody jump in that wants to.
And because of you, Jeff, and you guys, you both Jeffs are inspiration to us. In fact, that's the first reason. Because we learned, we grew our networking career reading your book, and even Jeff, lot of standards we learned when we work together. So that's the first aspect. And Michal and Himanshu also add on that. We have read a lot of research papers, and even we filed a patent for related to AI data center infrastructure. But I think a few years back, we were sitting together and discussing how to share this knowledge to our networking community. And we are doing a lot of ideas and coming up with a new concept in the design in the networking infrastructure, specifically in AI data center. So we thought of sharing that knowledge to the people, and inspiration by you and Jeff, like we thought of writing a book. That is the main reason, Jeff. And Michal and Himanshu, you can also add a few more points.
No, definitely, Jeff, when we met in Sunnyvale the other day, that was some time ago now, but definitely that meeting was, in fact, with Himanshu also on that day. We discussed very briefly, and then we just decided, hey, there are more and more people convincing us.
The time we did the video?
The video,
yes.
yeah.
Oh,
yeah.
Yeah, that's been a while.
Yeah, exactly. Yeah. And then the other part is when we talk about these new technologies, right? Well, of course, some of them are just in continuity with what the networking industry is doing for quite some time now. But also some customers were simply asking, hey, there are no real good source, right, of information, just partial information, blogs. So that was also one of the motivation, right?
Yeah. I mean, I can tell you that what impressed me about the book is when it says AI data center network design and technologies, title of the book, and title of this this particular show, I realized that there are multiple books out there that are like, go into configuring BGP, EVPN, or something like that. Our mutual friend Ananda Chatterjee has a terrific book. In fact, we need to get him on the show sometime soon on just that piece. But there's I've never seen a book like this one that is holistic around everything from the basic technologies, the basic dealing with the workflows and all that kind of stuff, all the way down to rack designs and environment and all of that kind of thing. And have you ever seen a book like that before?
So, Mike, as a compliment, I just read the book in 3 nights, right? Book is an extremely readable example of how a book should be written.
Yeah.
I mean, if it's too dry, eventually you will read it in 3 months, you will forget first chapter by the time you get to the last one, right? So it's exciting, it's well written, and even though the three authors, you don't feel the difference. Sometimes you read, this chapter is written, but this chapter is different. It's
Yeah.
one voice, one coherent way of describing the technology. And if you're someone who is looking for a job in the area, I think the book is must have. It's really, really well written.
Thank
It
you.
goes into right level of depth. Again, I can bore you with details on just a nickel implementation probably for the last 16 hours, right? And it's not going to be any good for anyone. The book keeps exactly level details you need to understand as network engineer, to understand where technology is or was at this particular point when book was written, and understand the evolution kind of the book. And again, well done, guys. I know how much effort it takes to write a book. Been there, couldn't.
Thank
Yeah,
you.
and
Thank you so much, Jeff.
rather than us just talking about it, I really want to hear from you guys. And what do you see? Maybe I might be framing this question a bit wrong, but what do you see in terms of industry trends that really motivates this book that is new information out there?
Himanshu, usually we will discuss about this one in many forums. The key trend here, data center is a data center, Jeff. Everybody, we know that, right?
Mhm.
And each and every data center type, starting from even many conference also, you mentioned that even you take like enterprise data centers, telco data centers, 5G data centers, even the financial sector data centers, storage data centers, or even the AI data center, the latest trend, right? Each and every data centers, even from the low, mid, large enterprise market and in cloud market, everybody using the same cloud architecture, leaf and spine, no changes, right?
Mhm.
Changes starts from the workload behavior and workload needs and feeds. There is usually how I would say the workload behavior define the server needs and feeds. The server needs and feeds will design the data center design. So
Mhm.
that is the key point. I would say it's a seed for a data center. So special in the AI data center is the RDMA traffic, and you guys know very well, Jeff. You also explain about RDMA in many forums. So how you are going to transport the RDMA from one server to other server? That is the key. I would say 95% of the training backend cluster handling the RDMA needs to handle very gracefully. It can be different technology, but that's a core. That is our kind of a seed to build this whole book, Jeff. And Himanshu or Mikhail, if you want to add something, please go ahead and do that. Yeah.
Yeah. So the idea behind the book, you asked for the motivation, right? So for me, more than motivation, it was Mahesh was my manager and he wanted to write the book. So he came, he said, let's write it.
Always do what the boss
So,
says.
yes. So I didn't have an option. But having said that, when I started putting down words, then I realized I know very little about this whole thing. There are more things to learn, and by each pace I continue to explore more and more. So started doing packet captures, trying to understand like how the transfer is happening. Having read the traditional books, like all the books till now, there is a way that we as network engineers understand the exchange of the control plane messages and handshakes. So I thought let's write similar way for the RDMA also. So that's how it started, and it took some time. Like it took a very long time to put together pages, and it grew. We have tried to cover the technologies from the point of view of the problems in or the challenges in the AIML data centers, and how one person should approach to fix those issues. What are the technologies that are available? And we have tried to keep it open and not say that these are the things that one should use, but it's like these are the options that you have it available, and then based on this you come up with your own solution. You if you know the problem, if you know available solution, you can always think of other solutions to solve this similar problem in a better way. So that's one of the approach that I tried to follow in the part that I've written. Yeah.
And
Yeah.
I would just say, in what you're talking about, it just chapter 1 of the book, that covers all the basic concepts. It really goes to what you were saying, Mahesh, of it's the traffic, it's the loads and the workflows that really define how you design the network, and that probably applies to any network. And when you're looking at specifically AI-centric networks, I mean, there are the workloads are so unique, and the challenges are so unique. And there's that first chapter just does a good job of laying out, here's what we've got to deal with, and have to design a network around.
And to emphasize my point, why I think the book is must-have, it's a combination of all resources in one place.
Yeah.
Right. So it's very convenient. On another side, it's a book written by network engineers for network engineers.
Yeah.
So again, there's probably 2,000 papers just published this year on AI and networking issues around it. Most of them are written by AI people for AI people. When you try to extrapolate information for networking, it's non-obvious. It's very difficult, actually.
Yeah.
Right. So, but if you're a network engineer, you read it, you understand. You've been there before, right? And I think the kind of the overlap of this base of information that you will need to progress on the journey, as well as the way it is presented. So again, network engineer to network engineer makes it extremely readable, and even though it's new material, it's very familiar, right? It's in a way what we've been doing for a long time.
Yeah.
So,
There's a book I'm reading right now on artificial intelligence. It's an enormous book. Really just reading that to have an understanding of what's going on behind the workflows and all of that sort of thing. But not a word in here about networking.
So the interesting point, this kind of books, they describe past very, very well. But by the time they're released, even the present, forget about future, is completely different, right? We change technologies every 3-4 months. Collective library change completely every 3-4 months. Networking and its foundation, first principle, stays the same, right? There's optimization. If you look at my BGP, it looks nothing like any other BGP, right? It does a lot of stuff that BGP doesn't do anywhere outside of what I do. But practically, it's still BGP. It does best pass. It's BGP for all practical reasons. You see the different data, right? So again, it's so familiar, and so you feel warm if you're a network engineer. You know what it is. You've been there. It's familiar, and you feel good while reading it because it builds on top of what you already know. It doesn't come and tells you, "Oh, look, this is MIE, and this is how you distribute it," and you think.
No, and we covered hardware as well as the software pieces, right? And hardware influence software. Software, of course, is dependent on the platform, on the hardware you're using. And so, since Jeff, you asked about the evolutions, right? So now the question is, which portions of the software will be moving from the CPU, traditionally from the CPU, directly into the ASIC, right? So that's also the type of evolutions we'll be observing, right? Besides all the intelligence, which will more and more sit probably on the NIC cards, right? In the context of the AI data centers, more and more. But still, at the ASIC level of the networking components, I feel like more and more things are moving directly into the ASIC, right? But of course, time will show, right?
That's true, but first principles stay exactly the same. So when you think about end-to-end evolution, it's no different than what we did 10 or 20 years ago. The workloads are different, the requirements are different, but first principles are exactly the same. This is distributed system. Unless you understand end-to-end system behavior, you'll screw in the way.
A question I've got, chapter 2 is sort of goes into sort of obviously takes the problems presented in chapter 1 and sort of gives you a broad overview that leads into the rest of the book on, here's very broadly how you address all of this. So, and one of the things I noticed in there, and it actually took me a minute, I had to think about it, but there's really 3 data center types. When you're talking specifically around AI, there's the inference, there's training, and there's storage. And you refer to inference data centers, storage data centers, and training data centers, because they all have different challenges, different duties, and all of that. And it took me a minute reading the book, to think, well, are these physically separated data centers, or were you just talking about, different types of data centers within one building that are still interconnected? Does that make any sense?
I can comment on this. So if you look at any hyperscale cloud, the front-end network is usually your regular hyperscale network, right? So if you have storage, someone in Azure or Google, usually you would go out to this cluster because this is where the infrastructure is. Been around for a long time. They know how to deliver storage traffic at scale. So there are very few requirements from this perspective that have changed. Potentially, we are moving from TCP to RDMA also for storage. But again, depending on hyperscaler, there's hyperscaler that have 2 zettabytes of RDMA traffic just for storage, right? So,
So essentially, the front end is the inference.
It's a traditional data center. You do need to make sure there's enough bandwidth, that reliability is there, because if your front end doesn't work, guess what? Your backend is not going to work either. You need to synchronize. You need to checkpoint. Now with video and all other stuff, there's so much data that's moving around. And if you're not capable of doing it in time, so checkpointing is fundamental, right? Especially if you do synchronous checkpoint, you don't start new checkpoint before last one. And if you do asynchronous, even worse. If you start new session before you end the old one, you'll screw both. So your checkpoint is going to go to nowhere, right? And if, God forbid, something breaks, and you actually need to start from checkpoint, it's not there. So doing properly front end is becoming more and more critical.
Super critical. I totally agree that, Jeff. In fact, the 3 infrastructure you mentioned, right, Jeff? There's each and every types within the same A infrastructure have their own job. For example, if you're talking about storage data center, the memory bandwidth, how fast, how efficiently the read-write operations are happening to feed into the training cluster. The data sets needs to be feed into the training cluster to train the particular model or something, right? But inference, I said, Jeff is, I totally agree with Jeff. Inference, specifically large context AI and edge content delivery, all those things, the inference matters a lot. But you guys know, whatever training infrastructure we are building, inference is the place where companies are making money. so inference becomes so important. Latency becomes so important. Reliability and a lot of things are important in inference side. There are set of requirements also changing from the training data center to inference data centers. That training data center, in our opinion, Jeff, please correct me if I'm wrong. In the training, most of the time, how efficiently, without any drop, you're transferring the data memory chunk, that gradients moving from one server to other server. In the inference, how efficiently, how quickly you are responding. For example, if I'm typing some prompt, how the pre-fill and decode working very quickly to respond to the customer. That's where the money is, right? So the requirements are totally different, changing. Now, answer to your question, in the book, the overall AI data center, it's not just a one data center, one type of a job. It's a kind of a different type of a job, different kind of data center infrastructure we need it. So high level, we put it as a training, inference, and storage. Um, and where the common people can understand. That's the reason the topic itself, the common man view, Jeff. So yeah.
Yeah,
Yeah,
I hear
and
very often, like network engineers, things needs to be really simple. Yeah, I'm not saying we are at the time where only you need to know about how to configure a VLAN on the trunk, but definitely, that simplification is important since people are handling in a production environment very often many things at the same time. And from the inference perspective, yeah, that latency part is one thing. But what I observed recently is like the number of applications, right, which are appearing on the market is increasing much faster comparing to what you see in the training domain, right? So these things will evolve, but traditionally the architecture, leaf spine type of topology for larger cluster, leaf spine, super spine, that's still the case. Although in the book we cover other type of architectures, so that's the interesting part, right?
yeah, and that which kind of leads into chapter 3 as far as to be just my nerd brain. That's the fun part is the training the training challenges and the training architecture, because that's so different from traditional vanilla data centers. The kinds of things that have to be addressed, and Himanshu, you mentioned early on RDMA, just the technologies around making RDMA work across hugely complex GPU clusters. I mean, NVIDIA pretty much owns I know there's others out there, but NVIDIA pretty much owns the GPU server market, it seems like. So you have servers with say 8 GPUs, but then altogether in a training data center, there might be 64,000 or more GPUs, and the load, the processing load, has to be spread. Just trying to verbalize a bit on the kind of challenges that go into an AI data center, but the workload has to be spread across all of these GPUs if you want to have any kind of timely results, and the results have to be accurate. That pretty much every job is delayed if you just have one piece of that job that is inaccurate or delayed or whatever.
Weakest link
Those are some of the
defines the outcome. Yes.
What's that? Say again.
Weakest link defines the outcome.
Absolutely.
Right. Yeah.
Absolutely. Man, and it's an enormously complex problem.
Yeah, and to add to that another dimension, usually when we build data center, we make assumptions about traffic patterns and overall behavior for next 3 years.
Yeah.
Not true anymore. Every 6 months, traffic patterns changes completely.
Yes.
We go from dense model to MIE. Nothing stays the same. So you need to be able to reuse same infrastructure that has kind of depreciation cycle of 3-4 years, and probably you don't want to go on the cable stuff or change stuff, do heart surgery on fly, but you need to be able to adjust and adapt like in runtime, because things are changing so fast. We've never seen something like that in networking history. So that's another level of complexity, kind of another dimension to it. What you build need to be changed, and in runtime, and much before you can financially afford to change your hardware, right? It must be done on the same hardware, but in a completely different way.
Yeah.
I think on the software optimizations, the bigger organizations are continuously changing these things, right? I mean, from the lab teams that are working on, like emulating or simulating the training activities, we keep hearing that these things are like giving results from one release to another. So a lot of the optimizations are really on the software side of the workload, right? So that the behavior, let's say there's a chapter about the KPIs in the book, right?
Yeah.
So in fact, the KPIs you're getting will be, of course, different in function of the software optimizations from the software stack which you are running on the server.
And kind of looking from pure economics or economy of scale, if you improve your, I don't know, Outlook network capacity by 2%, who cares? If you improve by 2% on the AI data center, we are talking literally tens, $100 million.
Yep.
Yeah.
Right. So, Jeff, you were mentioning about the change of traffic patterns every 6 months, right? So, does it really cause any concern for the networking perspective? Like, do we need to worry a lot about networking every 6 months, or is it until it is about increasing the throughput? Do we really need to worry about the networking part, like every 6 months, even if the traffic pattern is changing?
It's a very good question. So practically, when you build data center, you need to be able to foresee at least next 18 months, right? Because if you don't, you might actually end up in a situation when your hardware is capable of it. What's interesting about changing traffic patterns on networking side, it affects anything from congestion control. So congestion control for particular distribution and collect operation would be very different from one we used before. So you need to be able to fine tune and understand correlation across all the layers, buffer allocation to how aggressive your CC is, right? So again, it requires particular skill set and something you need to think about. You really need to understand this stuff.
Okay.
Number two is, again, I'm kind of coming back to the point every time. You need to understand end-to-end. If you don't understand, if you know how to configure, pardon my French, VLAN on a switch, there's no value in what you do. You really need to understand what happens when I go from this kind of model to that kind of model, what needs to be done on end-to-end networking side of things. If you don't, it's not going to work.
Jeff, and also that if you're Himanshu, to ask your question, right? The traffic patterns are changing. You know that, right? Earlier, we usually read some research paper here and there, but nowadays, every day there is one research paper, right? And we need to consider the traffic pattern. I would say yes, because even starting from basic collective operations, where the collective operation happening now in the server side, right? Now there is a people are talking about how the collective operation can be done in the switch side, the intelligence on the switch or intelligence on NIC or intelligence on overall. As for Jeff, you need to understand end to end, then only you can build a rock solid network design for AI infrastructures. If you're not understanding the traffic pattern, only looking for a throughput, you are not solving the problem holistically. So that's my opinion, and that's how we need to lead that next gen data center in that way.
But on the other hand, like traditionally as a network engineers, we used to, like, if you work on a production project, right? So then usually you were asked, like, for the application teams to build a matrix of flows, right? Yeah. If you look at this in the context of the training, right? Well, the characteristics of one flow, maybe you have a lot of them, but the number of type of flows you have is probably limited, right? So that's a difference comparing to what we used to have, or what we may have in the front end network, right? Which Jeff was asking about. So I think that's the also difference in terms of the training infrastructures, right? The number of flows is so much reduced comparing to traditional DC.
Okay, so if I understand correctly, so there is enhancements from the ASICs perspective or the software features perspective that drives the revisiting the data center design, or
they don't really drive, they follow applications need.
Okay. Yeah.
On our side, especially if you look at service providers, forget about it. You would go to a customer and tell, look, I built this new 3 or 5 chipset, it can do so many beautiful things. And then go think what they can do. Here, nothing of this type. There's an application with particular requirements, and you better be able to do this in your ASIC, right? Or else.
Yeah.
How much do you see out of that as far as, because I know that, obviously, incumbents, Juniper, Arista, Cisco are addressing all of this, and relatively newer companies like NVIDIA, although NVIDIA is very established now, but comparatively a little bit new, is certainly addressing it. And then there's startups popping up that are creating switches, that are purpose designed for AI data centers. And how much do you see out of the just generalized across the board for switches? How much do you see AI data center requirements influencing how switches are designed? Is it still just kind of the same, just higher powered, or are there unique differences in the in how they're built?
Yeah. I will take a cut here, right? This is a very interesting angle to see, Jeff, in my opinion. Um, uh, for me, even when we defined the data center network fabric for software stack 2.5 3 years before, right, Michael and Himanshu, we coined two common words. Not coined the word, we didn't introduce the word, but we used the word and we populate the word across the company. The two words, congestion avoidance and congestion control. Even
Yeah.
Jeff also mentioned congestion control, right? Any company under the planet Earth who want to handle the AI traffic, end of the day, they have to avoid the congestion. First step. If in case they couldn't avoid the congestion, they should have some efficient way to control the congestion. If these two are solved effectively and efficiently, then that vendor will become big, any vendor, right? And one more point, which is very important now, each and every executive briefing or customer meeting, which I am encountering, it is the energy. If the switch solves a congestion avoidance, congestion control, and power efficiency, that switches will be the perfect switch for any AI infrastructure data center. That's my 2 cents, and people can
Yeah,
add.
well,
I
Jeff,
would say
look,
5% of what makes an AI switch, but
I switch, but in fact, that power aspect is I mean, this is huge, right? I talked to some customers. I started to talk a little bit similarly, like Mahesh is doing about the congestion, but immediately the customer just said, "Hey, I want to talk power," right? So, in fact, that power aspect is huge, right? When designing the new DC, the new site, right, a greenfield deployment, this is the first topic that is thrown for any of the new deployment, right? So, and especially if you think about the 800 gig, 1.6 tera, 3.2 tera per port, right? That density of ports is going from 64 to 128, right? And probably more. Then of course some optimizations needs to happen. Is it still required for just traditional DCs or front end? Not necessarily, but on for the training part, definitely yes. That cooling aspect is evolving, right? And we will see more and more liquid cooled architectures, which are so interesting, right? Or for example, the co-package optics. That's the new trend we are seeing on the market as well. So these things are highly evolving, especially in the context of the AI data centers, not necessarily for the traditional DCs, right?
yes,
I mean, we've talked.
I'll touch upon a couple of them. Reducing power consumption of ASIC itself is not so interesting in kind of global envelope of power consumption. What consumes 80% of the power on your switch? Those are your optics, right?
Optics gauge, yeah, 100%. Yeah.
Again, if you look at optical side versus ASIC side, optimization of ASIC to reduce power consumption is very, very complex thing because you really need to go fast. And total win could be potentially less than 2-3% of total power consumption. Going from pluggables to CPO, this is where the true savings are, because you're consuming 30% of the power that you would have consumed with pluggable optics. Another very important thing is reliability, right? The density of data centers is just insane, right? It's literally millions of links. Being able to increase reliability by 50% going back to money, it in terms of OpEx brings millions and millions of dollars, right? Reliability of CPO is order of magnitude better than reliability of regular pluggable optics. So to Michal's point, movement to CPO is pretty much inevitable. It's happening. It has a variety of reasons. So we talked about power consumption, reliability, potentially price points. So this is where we are going from my perspective.
Yeah, and that predictability of any failure is, I mean, that's what. So there is that connection in between hardware and software. How software can help to predict any form of failures, right? On the optics, especially on 1.6 tera, this is huge, right? How much bandwidth you can lose just because there is some degradation in terms of quality, right? So if software can help with that, awesome, right? So that's what we will see probably in the coming couple of years, right?
In fact, one chapter we covered about optics very importantly because we feel the pain. In fact, Jeff, as Jeff and Michael is saying, right, when we had done some kind of a thermal footprint kind of a test kind of a thing, there are three places the thermal footprints are so high in a switch. Since you asked about switch, right? One is that, of course, ASIC, and another one is the CPU. But the majority of the thermal footprint so high is the optical cage, and that's where you need to cool down. That's where, if the thermal footprint is so high, you need more power to cool it down, right? And that's why, even in fact, the LPO, LRO, and CPO is helping us to reduce the power consumptions. For example, my number may be a little bit wrong, but a range from like 800 gig, if you are taking around, it will be take around like 16 to 20 watt. But if you CPO or any co-package latest technology will take it out, you will reduce it to 7 to 12 watt, and that much power efficiency you will get it from this latest optics technologies.
And spare each optical interface, right?
Yeah, that's very important question. Every port I'm selling that much power consumption, we are saving it, right? So going towards the co-packaged optics is important. And also I will repeat what Jeff also saying. It's not only power consumption reducing, reliability. If a normal optics have a DPS, there is unpredictable failure anytime it can happen, right? Even though the mean time up is so high for 5 years for optics, but for example, 50,000 cluster or 10,000 GP cluster, within 21 minutes, you will see first failure in the optics. So, I mean, this paper written, I was just quoting that particular numbers. So reliability is also so important. So this kind of a co-packaged optics will be helpful to get the reliability perfectly good for the A infrastructure, in my opinion.
And we spent so much time and effort to make routing protocols more reliable, react faster. You know what's the best way?
Well, it's just when I first started getting involved in the AI networking environment, I mean, it came as a shock to me. Optics are always expensive, but looking at pluggable optics and that sort of thing, and what they cost at the speeds that are being deployed now, and we're talking about 400 and 800 gig, and now 1.6 terabits, and probably right around the corner 3.2 terabit. The cost of optics is enormous. And then you combine that looking at, just right there in your book, if you look at, a lot of the designs around, like a good rail optimized design, or, or whatever topology you're using. And it's like an enormous number of connections. And you start realizing, optics are such a huge part of the expense of a data center. Yeah. Most people just think about the servers. And do you have any thoughts around, what percentage of the entire data center cost is eaten up by optics?
I do.
I was including you in this question because I knew you would know.
So it's significant. It's very significant. So total cost of networking could be between 15 and 25%, and optics are probably the most of it. But I think And going back to architecture, we've always been trying to save on optics, right? That's very cost sensitive point. You would be going over cents per optic. There's a strong mindset in AI data centers. If you are saving somewhere, you need to understand what it does to other parts, really application layer, right? If you can save 10% of your optics, but your reliability goes down by 5%, your ability to replace goes out to 4 hours more. If you do kind of total picture, suddenly you're losing, you're not winning. So again, back to end, you really need to understand what's important, and it's really performance of your application. So reliability, again, while power consumption is still very important, because every watt that's not going to GPU, every watt that's going to networking is not going to GPU, right? So you're kind of losing per definition.
Yeah.
But you really need to find a balance between quality of the hardware that you're using, suitability of the hardware to this very, very high rates. So traditional training network, we are trying to keep it around 96% of overall consumption, right? It's very high. No network before would do this. And this kind of, this requires a lot of efficiency in hardware design. You are not 80% idle and then you go into peak. You are 90% of the time really, really doing a lot of work. So you need to understand this when you build your hardware, and potentially saving or buying cheaper, or not necessarily cheaper, not as well designed hardware might result in very, very poor performance on the application side. So this is something, as network architect, you absolutely need to understand and understand the right trade-offs that you make when you design end-to-end.
Yeah. Reliability is also very important because of the cost of optics, we can't have as much redundancy as we want to have the reliability. So it's very important to have good quality optics which can last longer and not lead
well, from recent technologies like LPO, to your point, Himanshu, right? Like the LPO, linear pluggable optics, where the signal integrity is also kind of a pushed from the silicon itself, from the ASIC, right? Instead of the DSP sitting on the optics. That's another technology which is kind of evolving in the space of the data centers, and is recent with the standardization, which is just completed very recently, right? And that cuts of like 50% the whole power consumption per optics. That's the estimation, of course.
And I think another kind of somewhat related, sorry, Jeff, I'll finish in.
No, go ahead.
Somewhat related topic, we are going wider and thinner, right? So if before that you needed kind of more resiliency, you would just connect more links, you would just build locks here and there, and say something fails, I still have other lock constituents to take. Given the amount of networks that we need, we are trying to build wider and wider radixes, right? So we are at 5 FAB today, going to 1,000 reasonably soon, right? At this point in time, anytime you double the links between pair of devices, you reduce your radix twice, right? So it's not something you can afford when you're building at really large scale. So reliability is becoming even more important, because now you have no resiliency on link level between different switches. And any large network, really large network today, would fully utilize radix and try to go thinner, so potentially going to 200 gig rather than 800 gig, slicing it thinner and thinner to the degree you could go as wide as you can without introducing layer of super spines, for example, right? I think that's one of very important trends.
I totally agree. Don't know the reliability, right? Since Himanshu, you're all asking, that DSP, what Michael you mentioned, the digital signal processor, the clock and they will say the CDRs. So that is the part in the optics is unpredictable. Because of that, the failure can happen anytime, right? And so what happened, this LPO, for example, linear pluggable optics, they have tried to avoid the DSP. But more and more, if you go CPO is the superb example. So all the signal processing things, they are co-packaged with optics, the ASIC. That's nothing but CPU, right? Co-packaged optics. And then there is a new trend coming in called NPO, right? Near the optics, near packaged optics, and it will be near to the ASIC, not to the optical cage. So we are solving the problem. What problem we are solving? Reliability. And so we want to take out all the digital signal processing and clock recovery, everything close to the ASIC, not to the cable connectivity and the single optics where we are connecting it. And that's where the trend is going on. And it's a good
Mhm.
trend, to be honest. That's how we can solve this unpredictable errors and failures in the network.
And this is where LPOs and LROs come in,
LPO,
right?
LRO, CPO, NPO, the NPO also come into the picture.
Mhm.
Um, since we are going into
But
the topic, I have a kind of a question now. I'm thinking now loudly. If the failure happened even in the co-packaged optics, earlier, if the optics DSP some failure happened, we'll remove the optics, we'll put another optics, right? Easily, like
Yeah.
rip and replace. If anything happened, if the co-packaging near to the ASIC, if anything happened, failure happened, we need to change the whole chassis. This is another, maybe Jeff, you can correct me. This is my question, in fact. How this will solve?
So the most commonly failing part is laser. So in order to increase reliability, and this is what we did at least in our implementation, the laser part of it is hot swappable and replaceable. So you don't need to throw away entire chassis. You just remove the laser, you plug new one, you are done. So you need to think when you design hardware from this perspective.
Perfect. And thank you very much.
Yeah.
So this will dotted line to your first question, Jeff, that new infrastructure, new vendors are coming in, new startups are coming in to build the AI switches, AI data center switches. They have to think these all the aspects. And all the vendors have to think
But we
about these
talked
things.
optics, right? And then Jeff T, you mentioned also that like throwing 200 gig instead of just putting everything on like 800, 1.6 tera. So there are also repercussions like on the design aspects, right? Since the book is about the
I was
design,
going exactly there.
right?
Yeah.
So maybe
Yeah.
I read your mind. Maybe we can also talk about that part, since there are things like how you design the multi-planar part, right?
That's
That's the emerging trend of designs, where
Yeah.
sometimes people are saying, okay, for the reliability, we talk about the reliability of the networks, and as a matter of fact, right, that reliability can be improved with the multi-planar part, right? So please,
yeah.
Jeff, go ahead with that part.
So those of us who work for hyperscaler, the multiplanar networks are nothing new, right? But fundamentally new is where you start the plane. So if you look at any hyperscale network, you will have spine groups. So plane starts at the leaf switch. Leaf switch connects into a particular plane, and this allows you to build number of independent entities. And when you go into maintenance, it allows you to maintain a slice of the piece. So usually you would have 4, 8, sometimes 16 planes. Then some are very high planes, usually merge or at least half merge. So again, if you're familiar with any large hyperscaler, you would see something like that, right? But again, the NIC is not aware of any of this. The difference now with multiplanary networks in AI is that planarization is moving to the NIC.
Yes.
So think
NIC
about
acting as a
it. Yeah.
the,
When
yeah.
your NIC chooses a particular plane, you're in a tunnel. There's no way you can escape and get into another plane, which brings a lot of complexity to the edge. And actually, this is where complexity belongs, right? We all know that complexity should be at the edge, not in the middle of the network. This is the core of MPLS understanding, right? So practically now on the NIC, you need to understand which plane to use, how to use it, what if there's a failure, what if there's congestion. So there's huge amount of work in this area to
and
make.
either take a local decision at the NIC card, or through some form of controlled overall view of what's going on in each of the plane, right?
Yeah, so that's an interesting point.
Not necessarily solve as a problem, right?
Yeah. So interesting point whether you do it, and again, I think it's kind of fundamental networking question, whether you do it centrally or distributed, right? We always see this. SDN OpenFlow solves all your issues. We build a particular site, it breaks down, we go fully distributed, but then the complexity becomes too high, we go centralized again. I think we have a couple of slides with Ross White and the observer with 40 years of pendling, right? So here,
we started working on multi-planners with a very hyperscaler customer environment, very high scale. And Mikhail, you know that, right? Our fabric coloring, one of our patent, it's in the switch. Switch, we are doing kind of a different coloring method, but the multi-planner is very interesting one. It starts from the NIC as Jeff said, right? And so it is distributing the traffic in the different planes. So for maybe for the redundancy, and if one pod is failed, it will take another pod, another plane. Also that they are saying some cost efficiency. That's what I also hear from one of the YouTube videos. Jeff, you also posted in somewhere the first principles and all. That's really very good. Superbly they explain about it. That's an interesting topic which is evolving with high scale A infrastructure.
so we always start with very high scale because this is where the money is, right? But eventually all these technologies trickle down to smaller data centers, to enterprises. It increases resiliency because if you look at design as such, usually there's a number of parallel fabrics that don't interact with each other, right? If one fabric fails, you still have 3 or 8 fabrics to go through. But it requires very good understanding on the NIC side and software side, when to use plane, when not to use plane. And don't forget about scale. We are talking about 100,000 endpoints that somehow need to coordinate who is sending to whom over which plane, how this plane is reachable, what do I do if something fails. It's a huge development from an industry perspective. It's really complicated, but it's also very exciting because it allows you to build much more reliable and scalable networks.
Well, and Jeff, you hit on exactly the question I was going to ask. Is out of all of the things that are so AI data center specific right now, as you said, they trickle down into smaller data centers and out into enterprise. What do you guys see? Just personal views of what is innovative right now with AI data centers that's going to specifically or particularly influence how we build more generalized data centers in the future. And I'm just looking for opinions here. No, nobody's going to ask for confidence levels or anything.
That the more generalized data center will be related to AI infrastructure. I'm telling you, Jeff, because even starting from finance segment or cloud segment, neo cloud is mainly meant for AI infrastructures, right? So whoever having a general data centers, they will be having a touch point for AI infrastructure because people have started investing in AI infrastructures, right? Even enterprise, we are no need to think the big player only investing in AI infrastructure. No, even enterprise, even they are not building a training infrastructure. That's the reason they are going to neo clouds. They're putting a money on the neo clouds to build AI infrastructure for them. So there is, in my opinion, all the data centers are going to be a touch of AI, to be honest. Okay, and that's how the data is going to processing. Whatever data we are transacting, now there is a touch with AI, right? They want to use the data to train or inference, all those stuff. They're doing it. That's my opinion. Michael, Jeff, or Himanshu, you can put your color on that. Yeah.
Yeah. So sorry, I just jumped into it. I really like to think of it from kind of, in a way, the AI that kind of proliferating all of this technology is generative AI.
Yeah.
Right. So it's there to generate. We usually talk about tokens, but practically it generates intelligence and logic, right? So it doesn't really matter what you are building at what scale. Eventually, you would like your data center not only to be the cost center traditionally, like infrastructure for your databases, but you would also like it to generate more intelligence because per definition, something that generates something much better than something that just consumes something, right? So And from this perspective, I very much agree. I believe a lot of data center designs are going to be more and more crafted in a way they can cater to both regular workloads of basic CPU, what we did for the last 30 years, as well as providing some infrastructure GPU, because inference is per definition distributed, right? One way or another. So you need to be
yeah, and probably also collapsing sometimes if the density, of course, of the platforms is increasing in terms of number of ports, then collapsing the layers, right? In many of the hyperscalers, I've seen like seven from T1, T0 to T5, T6, T7, right? I think this is like from the, let's say, very high level design perspective is just collapsing, in order to get even better performances, likely better latency, right? So that would be the evolution I'm seeing. If you think about this from the book also, there are some examples where we are seeing that people are like collapsing it down to even like just a handful of switches, but with ultra high density of ports, right?
And also kind of cadence of increasing speed, we really compressed it twice, right? So traditional cadence has been around 2 to 3 years, right? You go from 10 to 25, from 25 to 50, then to 100. Now we double pretty much every 14 months.
Yeah. Now we are talking about 100 gig SerDes. Now it is 200 gig SerDes with 1.60. Now already, Jeff, you introduced the word 3 terabit, which is 400 gig SerDes. We are going so quick.
Yeah.
But as Jeff first point he mentioned, the real fundamentals are not changing. We are enhancing it, but the networking concept are same. And so that's a very interesting factor in my opinion. Yeah.
But
Well, one
at
of
the
the
same
things
time-
that in one of your later chapters you talk about the Ultra Ethernet Forum, UEF. How much do you see? Because when I read UEF stuff, it's like, oh, this is really different from everything I've understood about Ethernet.
Yeah.
How much of a paradigm shift do you see UEC having on just Ethernet networking?
Yeah, and me, Michael, and Himanshu, we are closely working with a lot of Ultra Ethernet consortium concepts, and in our day-to-day work, with the take out that influence, any consortium, any enhancement which are taking, it will take at least 2 to 3 years, Jeff, to be honest, to mature that. Now, we love the concept and everything, but the main question is when we are going to productize it, when we can see it in our production grade level switches, right? That part is up to the vendors, switching vendors. They need to adopt it, and they need to adopt it in a massive way. And for example, if you're talking about GPU, I don't want to use the company word. Everybody talking one company, which is very close to Jeff, right? And like that, massively, people needs to talk about that one. That's where it's going. But they're solving a really good problems, right? The million nodes clusters in the UEC, and also we are trying to solve the congestion avoidance, congestion control in a very, very efficient way. Only thing is that when we are going to productize it, and
it's especially and to the point Mahesh is raising, it's mainly a NIC card optimization, right? And then that bringing a little bit more intelligence to the NIC card, comparing to what we have currently with the PFCs and ECNs from the DCQCN stock, right? But these optimizations are fixing some of the limitations from the existing Rocky V2 and the DCQCN stock, using some of the inspiration from other technologies, right? Or combining Ethernet with the inspiration from other technologies, right? Is definitely the motivation. But as Mahesh mentioned, it will take another maybe 2 years to 3 to see a nice diversity of the NIC cards on the market, supporting the full stack, right?
So I would like to make an analogy. There are two ways you can progress technology: evolution and revolution, right? UC has taken kind of clean slate approach, right? They want to replace their DMA, verbs, and whatnot. I think this creates significant hurdle for adoption and implementation, because practically you need to replace everything. And to some degree, I would compare it to IPv6, right? We know that when we kind of started IPv6, actually it was even before. I'm in my 50s, so the fact that we are still talking about IPv6 deployments is because of complete lack of compatibility with IPv4, right? For many reasons, some of them really religious. The decision was taken, we are going towards this new thing, and it doesn't need to interwork with this old thing.
Oh, yeah.
Wasn't this, we didn't have the internet yet, even, as we know it today. So practically, as a architect, you always need to think about deployability and interoperability, right? And I think it's very close to our hearts. And sometimes if you're 30 years with a vendor, you just don't have this inside. You just, let's just do it from scratch. There's no from scratch thing. If there are already deployments, try to change BGP, right? the hell will open. So there's a lot of valuable proposals. So I've been participating and somewhat driving UC when I was at Microsoft since day one. A lot of great ideas, but eventually some of this becomes really religious and political. Yeah. And then you end up with huge spec and bunch of slides, right? And there's difference between theory and practice.
Yeah. And I hate to cut this short. I've got a ton of questions I still like to ask, and I just now looked and realized we are actually a little bit past the top of the hour. So we probably should wrap this up. Guys, maybe we need to talk about having you back for another show, because I still have a lot of questions to ask. And this has been a great conversation, a lot of fun.
Yeah.
And I just maybe would like to wrap up by saying, do you guys have any concluding comments?
No, we want to wrap up.
Before you go, let's schedule second show. Not
Let's
just.
do. You guys are you guys up for that?
About routing.
Really good.
There's a couple of chapters we didn't discuss that are really great. So we are not saying
it's easy for me and Jeff to say. In the background, Robert, our producer, is probably crying right now because he's the one that has to do all the coordination. This show has been we've been very lucky with because we basically coordinated across 4 U.S. time zones. Europe, Michal, all the way to India, Himanshu, and somehow we all managed to get here. So
if you have the book in hand now, you guys have the book right now, Michal, it's with you.
Yeah, I have it. Yeah.
Oh, okay, that's good. That's good.
Yeah.
Okay.
Mine is in another room.
Okay.
Look at that.
Really great work. Pleasure to read.
Congratulations on a terrific book.
Yes.
Thank you.
And thank you so much for joining us today.
Thank you. And definitely we'll meet second. And thank you very much. Always, you guys, I honor always you both. And not only me, Michal and Himanshu. Thank you very much, Jeff. Yeah. And Robert too.
Thank you so much. And
Thanks,
again,
guys.
we're not saying goodbye. We are saying we will see you really soon.
We'll
Second.
see you soon. Yeah. So
and thank you to everybody watching.
Thanks to everybody that's watching. Really appreciate you joining. And as always, we'll see you at the next show.
See you. Bye.
See.
Thank you.
Thank you.